All right, folks, I think we're leveling off and we've got a bunch of stuff to talk about today. So I think we should just push this ball down the hill and get going here. So Peter, I'm just going to hand it over to you. I know you've got a lot of things that you want to show folks and troubleshooting something we all have to do. So
Yeah.
thankfully, plenty of great tools and yeah, Professor P, take it away.
I'm going to preface this that this troubleshooting is a lot of information shoved into a very short period of time. And so if you are interested, if you like this, we do have the Peplink Tech Summit coming up here next month where we go through the PCA training. But this is a snippet of our Module 4 training that we've decided to share with everybody and kind of make a university video to kind of give some ideas of Q&A and open up the ideas of the tools available for troubleshooting Peplinks, because there is a lot to our stuff and we keep every new feature set. We have more capabilities. We got to have the tools to troubleshoot the different connectivity scenarios. And so, anyways, I just wanted to preface that with there's a lot in this, so I expect that you're going to download the recording afterwards and watch it again, and just to keep up with all the different slides that we have. The learning objectives of today, and this once again, it's kind of like pulled right from the PCA training that we did for Frontier, and we're doing it at the PTS as well. But basic troubleshooting, so in other words, hardware-based feature sets that we're going to have to help you with visually troubleshooting the capabilities or the status of the router, and then the tests and tools that we have for optimizing and validating your network. So that's sort of where we are, the physical hardware, and then the tools that we have to troubleshoot, speed fusion and connectivity, WAN performance, is my speed fusion equal to my WAN performance, that kind of stuff.
Yeah, that makes sense.
Yeah. So you're going to have the LCD screen that's on the balance routers. And some people freak out. If you notice when you first starts up, there's that black bar. That's okay for a few seconds. If you have a permanent black bar, that's going to be bad. And then another funny one that people will complain about is when it boots up, they'll see maintenance and status. And I'll show that in just a second. It kind of fails through it here. Right. Booting. And then you're going to have system status and maintenance. That's your standard. That means the router's booted up. So if you see system status and maintenance, that's good. That means that router's up and it's booted up. On the left-hand side, you're going to have the max routers, and you're going to have your power, your status, Wi-Fi 1, Wi-Fi 2, or Wi-Fi only if it's like a BR2 Pro 5G or something like that. And then your cellulars, 1, 2, and then additionally, potentially 3 and 4. If those are on solid green, that means they're good. If they are flashing, if the cellulars are flashing, that means it's detected a SIM card and it's trying to connect to the internet. So it's going to go boot up, power, status, and then the cellulars are going to start flashing, which means they've initialized and they're starting to try to connect, and then they should go solid green. If you only have one Wi-Fi, like this one, Wi-Fi 2 is flashing or booting, starting up there. If you only have one Wi-Fi, that means you're in AP-WAN mode. That means one of your APs is being used for WAN and the other AP is being used for a Wi-Fi access point. If you see two green lights, Wi-Fi 1 and Wi-Fi 2, that means you're in AP mode. That means both modems, both modules are actually being used for Wi-Fi access point. And so if you try to do Wi-Fi WAN, it's going to say this Wi-Fi is disabled. And so if you want the best Wi-Fi performance, 2.4 and 5 gigahertz, you should see two solid green lights for the Wi-Fi. So in the dashboard, we're going to have WAN status, speed fusion status, Wi-Fi access point status, device information, and your IPsec VPN status if you have that. And so if we look at our different connecting, I actually recorded that yesterday, this initializing, connecting, obtaining IP address, connected. I created like a little GIF image there to show the status of a healthy boot up. So it's going to reset, it's going to initialize, it's going to connect, it's obtain IP address, and then it's going to go on to your T-Mobile. That is a healthy startup of a cellular module. But we have Ethernet WANs and cellular WANs. And so here's a kind of what each of these different ones means. No cable detected. That would be applying to Ethernet WAN, and that means it's not detecting a network an Ethernet cable plugged in. So that means you either have it plugged in and then the other side of that cable is not plugged in, or you're getting an MTU mismatch, or it's not negotiating. But either way, it's not detecting that cable. So you need to troubleshoot the physical cable and or the remote device. Status connecting, which means it's detected the cable or the SIM card, and it's negotiating and trying to establish how it's going to connect. Obtaining IP address means it's connected, it's established the negotiation with either the carrier or the network, the Ethernet, and it's trying to get an IP address from the provider that's going to do that. WAN failed DNS, WAN failed ping test or DNS or HTTP test. That means that the DNS server provided either statically or via DHCP is not pingable. So that's what it's going to do with a ping test by default or DNS test. A lot of people will just turn that off, go, oh, it shows connected, we're good. Maybe, but there's still a problem. If the router on the Ethernet WAN or the cellular WAN can't access or ping out to the internet, make sure that that's not just your firewall policies that you're plugging into, or make sure that it's that's an actual known event. Don't just disable the health check and go, oh, look, it shows connected. No SIM card detected is very similar to no cable detected. And so what we mean by that is it's not detecting that you've installed a SIM card. This could just be that you've installed the SIM card after the router is booted up, and it just didn't, when you plugged it in, it just didn't trigger that detection. Sometimes a simple reboot will fix that, or there's a reload SIM option that you can do as well. And so paying attention to that as well. No device detected. This means the cellular module is reset and it's waiting for it to respond, and it's part of SIM detection. So to no device detected is kind of a weird one. If you get stuck there, be careful. Give it a little bit of time, because it might have loaded a firmware, or might be detecting that the first time. So be careful on no device detected, just like rebooting the router or being impatient with that one, if you happen to see that. Connected means the connection is working and healthy. And then connected on, and that'd be your Wi-Fi WAN, letting you know that you're connected on a particular Wi-Fi network. Or in this case, you'll see connected to T-Mobile 5G. So kind of crazy, but there are meanings to all of these, and they do tell you, especially on the cellular side. If it says initializing, connecting, and then obtaining IP address, and it's spinning at obtaining IP address, that means it's detected a carrier. It's detected a tower, or it's established a connection to a tower, and it can't get an IP address. It could be a couple different things. One, it could be a bad account. So basically you're connected to T-Mobile, but your account's not active, and therefore it's not going to give you a DHCP address. Or it could be that you're connected to the wrong carrier, like you've selected T-Mobile and it's actually a Verizon. Or it could be that you have a private APN or a different APN, so the APN is wrong. Like, for example, if you have a static APN for T-Mobile, you might have to do b2b.static instead of the default fast.tmobile.com. And so you could have either an account issue, a carrier issue, or a APN issue is my typical, when it says obtaining IP address, it's stuck there. When we talk about speed fusion, I get this a lot, and there's a couple different things. One, speed fusion operates on port 4500 and 32015. And so it needs to be able to connect inbound to its host, whether that's your Peplink router in your office or to SpeedFusion Connect. And so we want to make sure that those ports are allowed out, whatever you're connecting using. If it's cellular, it's almost always allowed out, but just if it's a private APN with a firewall or some variant thereof. Authenticating means it's connected, and it is they can see each other and they're authenticating. Creating a tunnel means that authentication was detected, and the tunnel is now being configured. This could be that port 32015. So if you get the authenticating and it reboots, it means it discovered each other on 4500. It's creating the tunnel, which is that UDP, which is going to be on 32015. And so it could be that you're stuck in a loop because 4500 works and 32015 doesn't. Updating routes means that it's taking the known IP information. And this is where a lot of them fail, and it's really fast. If you have 3 routers and they all have 192.168.50.1, and they're all connecting to an SDX router in your office, and you don't have NAT enabled, because it's on the untagged LAN. When they connect, the first one's going to connect and it's going to work. The other two, they're going to go to updating route and they'll go back to starting. And there's going to be no warning there. It's just going to go updating routes, starting. And it's really fast. So go authenticating, connecting, creating tunnel, updating routes, starting. And that's because the untagged LAN is conflicted. So if you have an overlapping, conflicting, untagged LAN, you're going to get a loop at updating routes. You can have conflicting VLANs, VLANs on the network, and it'll say inactive. It'll mark those as inactive if they conflict. But if you have the untagged LAN, it's gonna loop at updating routes. So just be aware of that. And then established means that it negotiated, it's got its route tables properly advertised or NAT tables properly advertised, and you have a connection. On the Wi-Fi access points, I'm such a fan of in control nowadays with Wi-Fi or AP management, but we do have the SSIDs shown here. And so you'll see Wi-Fi AP in the name and then on. So you can toggle on and off the radio with the on off. You can also do that in control by toggling it on and off. If you see nothing there, blank under Wi-Fi AP, that means that you're using, usually, it means that you're using in control configuration and whatever SSIDs aren't being applied, either because of the tag, like you have an inappropriate tag assignment or some variant thereof. But if it's blank, if it boots up and it's blank, that usually means that you have some sort of tag association where the SSIDs and in control aren't being pushed or assigned to that router, typically. Otherwise, if it's a factory default or factory settings, you should see exactly what you see there, that peplink underscore and the last 4 of the serial number. And then you'll see there, you can also tell if it's broadcasting what channels. So 2.4 and 5 gigahertz. You can see that shows up right there. Then you have your AP controller information. This is really nice if you're managing multiple APs within the router itself. So it lets you know that the online one, that's probably the built-in AP. And then you have 6 APs and then 3 clients. So what this is saying is only one of your 6 APs is actually online right now. And those 3 clients are using that one AP. The dashboard has changed a lot. So I'm going to launch into my dashboard on my lab device here. So I'm going to go into my MBX HD4 that I have. So in 8.4 firmware, or actually kind of 8.3 and then 8.4, we've made a lot of UI changes, kind of unifying the balance and the Max series routers. And so it's nice to be able to say, hey, this UI will apply to both Max and balance-based routers. So the first thing you're going to have is your WAN connection status, and then those are going to be in priorities. It's important to know that that priority is the interface status. So if I have Google Fi in priority 1, my Verizon and T-Mobile will go into standby. If I have all 4 of those in priority 1 for Speed Fusion, only Google Fi will be active because I have Google Fi in priority 1. So this is think of this as like interface status or interface priority. Then you can have outbound policies and Speed Fusion tunnels that can use them, but they have to be on here in order for that to work. So you have your priorities where you can see the status there. Then you have your WANs, your cellulars, your Wi-Fi WANs, and then you can activate those. This is a troubleshooting, not a training on the dashboard. So I'm going to go into troubleshooting, but you can see the status and health of those right there. Additionally, if you click on the IP address over here, you're going to get all your cellular information like your IMEI, your SSID, your ICCID, and your signal strength. And then you have your untagged LAN interface here. So even if you have sub VLANs, they're not going to show up. This is your router's management interface that can't conflict if you're doing Speed Fusion. And here you'll see your Wi-Fi APs. So you can see I've got Rebel free Wi-Fi on 2.4, Renegade on 2.4 and 5, and then Renegade again on 2.4. And it's just labeled Renegade 24. And you can see there's my Speed Fusion VPN status and my SFC Protect status. And then more importantly, down below, I've got my 8.4 firmware, my uptime, my CPU, my power consumption, my temperature, and then I've got all my power inputs. I've got my DCA-B terminal block, and then what current throughput is being used. So the dashboard has gotten really good over the years and the different firmwares. So on cellular, if you click on cellular, you're going to get the the IMSI, the SIM card status. You can see in use. And then you'll have all your cellular details right there, including the model of the modem you have and the firmware of that modem right there in the details. Active sessions is a really good way to see what's happening on your network. Often I'm troubleshooting connectivity, and the first thing I do is I'll go to active sessions and see if it's even getting where it needs to go. Think of this as a simplified Wireshark. I kind of like showing you what's actively crossing through the network, but not all the details. So if you go to status, active sessions, and then overview is going to give you your clients, the total number of sessions, and then the number of sessions on each WAN. And I can hit refresh and it'll query and pull in the latest information. I can then go to search, refresh, and it'll show me what's happening on this router right this second. And given the fact that it's I just rebooted and tested, or just testing this router, there's really nothing going on right now. But if I pull up my BR2 Pro 5G that I'm using right now, you should see this Zoom call happening. And well, what's neat here is you can filter by source or destination IP address, ports, protocols, and interfaces. So if I want to see, hey, I've got some clients that are using BitTorrent, what are they using? Or if they've got VoIP, I can actually see what they're doing based on the protocol and service. You can select a service and see which interfaces or which connections that's using. I like to use it as a way of telling what's using SpeedFusion versus an Ethernet connection or a cellular connection. A lot of times, like, is my outbound policy working properly? Am I sending this out SpeedFusion, or am I sending this out a cellular connection? So a lot of times I use active sessions to tell me if my outbound policies are working the way they're supposed to. If that makes sense.
Exactly where I was going to go. This is one of my first sanity checks of like, okay, I've got everything set up, I've got my policies. Are things going where I expect them to? And sometimes they're not, right? And you can see it really quickly here when you've set everything to go through SpeedFusion, or so you thought, and you see things on a cellular interface or on an Ethernet interface. And yeah,
pull up
early warning.
Pull up my BR2 here, I should be able to see the Zoom call going on right now. So go to status, active sessions, search, refresh, and there it is right there, Zoom using SpeedFusion Gainesville. And you can see all my sessions going on right now from my laptop out to the internet using SpeedFusion. And you can see there's an IPsec going out, cellular 1 right there. And so awesome. So there's a better visibility of that. And once again, knowing that I'm sending all that traffic out SpeedFusion. This actually does bring up something I'm going to segue real fast. This IPsec going out cellular 1, this is an IPsec NAT issue. So I have a policy saying send all traffic to SpeedFusion, but this IPsec is going out cellular 1. Why? It should be going out SpeedFusion because I've told it to send all traffic out SpeedFusion. If you go to advanced, service pass-through, there's a checkbox, IPsec NAT-T. If you want your IPsec tunnels to go over SpeedFusion, especially if you're bonding Starlink and you want to take advantage of IPsec and your IPsec tunnels aren't establishing, turn this off. That's going to allow IPsec tunnels to follow outbound policies and go over SpeedFusion. If I hit save and apply, whatever that tunnel is will then drop and move over. So I'm not going to do it, but just letting you guys know it's there. Yeah, so you can search by protocol IP address. I just talked about that. Support.cgi. So If you're in your router's UI and you see up here the index, if I just double click and highlight index and change that to support. So I'm going to go to support.cgi in my URL. It's going to take you to a backend kind of support page for Peplink. There's a lot of things you can do here. One, LAN, WAN, Ethernet details. This is going to show you what's connected, but also it's going to show you your receive and transmit packets and errors, more importantly. So you can see drop packets and errors on those circuits, as well as the status and health of each of your WANs and your LAN, what you're negotiating. So if I'm negotiating 100 megabits per second, or I'm negotiating a gigabit, or I'm getting some frame drops and things like that, you can see that right here. You can also turn on remote assistance. You can download a diagnostic report, but then you can also run a network capture. So I can click show, choose my connection I'd like to capture on, hit start, and then I can actually download up to 20 megabytes of data on a network capture, and then load that into Wireshark and see exactly what's going on in my network. I can also remote capture, send this to an IP address and port and hit start, and it'll do that until the router reboots or until you click stop. So you can actually do a bigger capture and capture more data by sending that to a remote server, but the UI is limited to 20 megabytes or your free available storage. So if it's less than 20 megabytes, that means there's less than 20 megabytes of memory available on your router.
Yeah, 20 megabytes goes quick.
Definitely. Yeah, 20 megabytes goes very quick. You also have checking for cellular module firmware. So you can click check update and then push that. Highly recommended that if you're updating your cellular firmware, that you're connected to an Ethernet WAN. Take that router, plug in the Ethernet WAN, connect it to your network, drag the cellular connections to a lower priority so they're on, but not being used. Then update your cellular firmware. Don't try to push cellular firmware over cellular. It, in theory, sometimes will work, but more often causes more problems than it helps. You can also do health check failure simulation. So we're talking about troubleshooting. We can simulate a failure of an internet connection for 60 seconds. So I can click fail cellular 1, especially if I'm doing this remotely. It'll turn that off. It'll simulate a failure, and then 60 seconds later, turn that back on. So you can test it without risking losing permanent access to the router. And then probably the other neat thing down here is NetFlow. You can turn on your NetFlow here and enable your IPv4, V5, V9, or IPFix NetFlow right there. There's other things, but those are the troubleshooting. Yeah, so it's support.cgi. You can capture up to that 20 megabytes and then load that into Wireshark. Network capture uses system resources, RAM, and flash storage. Capture will automatically stop if resources run too low. Keep local capture small, like run your test just what you need. Don't run it unless you're doing a remote capture. Capture on multiple devices when needed, and then use remote capture if it's large content. The event log is another great tool, and Peplink's done a really good job of segregating out the logs. So you have your device log, your IPsec VPN log, your firewall log, and your SpeedFusion VPN log, and they've filtered those out for you as tabs now. So under status event log, you can see the different events that are happening on the net on your device, and then in real time, but also historically. But then all of those, if you have multiple devices, are rolled up into in control, and you can pull up the group or level event log and see all your devices and their WAN status and things like that. So if you want to do firewall logging, you have to turn on event log. If you go, oh, my firewall log is blank, it always is. You actually have to turn on event logging. And it's actually a common practice. Let me go back to the dashboard here. If I go to advanced access rules, the default deny policy actually doesn't allow event logging. So if you wanted to have a default deny, like in my inbound here, I could go add, and I go deny logging, and I could say any deny, and then enable event logging, save, and now I've got two of the same policies here, but that's actually going to be my deny logging. So if you want that default policy, like this default allow, I could click allow logging, any allow, enable, and then drag that down to the bottom. And then now I'm enabling. So I've got my denies, and then I've got my allows, and I'm logging that allow, and I'm logging the deny here. Once you enable logging, all that traffic will start to go into the event log. However, based on the size of your router, those logs will get purged if they're too long. So you want to pull those up in control, and you'll have better history. But based on the memory and resources available on the router, specific model, you might, depending on that, the logging uses up a lot of resources, and it's going to increase the amount of data transmitted to in control. So just be aware of that.
Yep. You can also use third-party like syslog servers and things like that to receive those. But yeah, I mean, to your point, Peter, those logs can get big fast if you're logging every little event, but sometimes you need to.
Yep. And we have the tools to do it if you need it. So basic troubleshooting things to avoid: if you're stuck in resetting mode, don't attempt unsafe or unhealthy shutdowns, and don't ever update a device while it's malfunctioning. That right there is the number one reason I wanted to have this session. I get trouble tickets all the time. They're having problems with the router. It's in an unhealthy condition, and they update the firmware as a way to fix it because they don't want to reset the router, and they don't want to. Don't do that. If the router's not working, don't update the firmware. First, you want to factory reset, make sure it's in a healthy state, even if it's a healthy state without the feature you need. Make sure it's in a healthy state, then update the firmware. If you have the firmware and if the router's in a healthy state, by all means, go ahead and update the firmware, keep your configuration, great. But if it's in an unhealthy state and you're trying to troubleshoot, you're trying to fix a problem, do it with a factory reset router. Don't do it with a production router or a production config, because that unhealthy configuration could go to your new router. I had a customer just on Friday night. I was actually down at Halloween Horror Nights and got an emergency text message. Hey, I'm having problems with this router. I'm going to update it to 8.4. I said, whoa. Factory reset it first. See if it fixes the problem. Got a text message about 10 minutes later, fixed the problem. They had a configuration error. Hold the reset button for 25 seconds, factory reset it. The cellular connections worked perfectly. Then they went ahead and safely updated to 8.4. But don't use firmware as a way of fixing a problem unless it's a known problem that the firmware is fixing that you're trying to achieve, like whatever's in the actual repair sheet, like in the release notes. Sorry, my brain farted there. And the release notes. So now we're gonna talk about some testing. Hopefully I have enough time. Yeah, okay, we're good on time. So WAN analysis, PEP VPN test, connection test, SpeedFusion VPN testing, GPS forwarding, diagnostic reports, geofencing, network optimization, and NetFlow. I'm not going to test all of those in this. Like I said, this is a snippet. What I'm going to do is overview that you can do it, and then I'm going to show you the ones that I find very valuable. So we'll go through the slides, and I'm actually going to show you WAN analysis, which I love, and I'm going to show you SpeedFusion test, which I also love. So otherwise, we're going to stay in the slides for those. WAN analysis basically requires two routers. It uses NetCup to establish a tunnel, or to establish the session, and it'll test each WAN circuit independently and give you your total throughput. You can then run the math on this minus your 18% overhead, and then that should give you your approximate SpeedFusion throughput. And so that's also a nice thing about it. And so the idea here is, though, that you can test each circuit and get the circuit information without just regular internet traffic. No SpeedFusion, no speedtest.net, or whatever it is that you might be using for performance. And so what you're doing is, from my router to my data center or my other router, this is the throughput that I'm getting raw. Very powerful tool. SpeedFusion test is, once you've done the WAN analysis, lets you know how those WANs are talking back to your host. So your latency, your packet loss, etc. And what's interesting is, I had a customer call me a couple weeks ago. They were doing a live broadcast, and they were getting massive packet loss, like 1,300 packets per second or 1,400 packets per second, when they only were getting like 6 megabits of throughput. Anything more than that, just massive packet loss. The customer's freaking out. Like, can we restart SpeedFusion? Can we reboot the router? Can we update the firmware? And I was like, well, hold on, let's take a look at it. I run a speed test. Sure enough, massive packet loss. Well, then I ran a WAN analyzer to my data center. I was just because I have access to that. So I spun up the host. I ran 0 packet loss, hundreds of megs of throughput. They were getting like 180, 190 megs of throughput. And I was like, that's weird. So then I logged into their router, ran a performance packet loss, massive packet loss at around 6 to 7 megabits per second. And I was like, huh, that's weird. I noticed that they were consuming around 40, 43, 42 megabits of usage. I clicked on the WAN to check the MTU to see what maybe it was wrong MTU or not negotiating properly. And I saw that they had set the speed to 50 megabits. So they had a 50 megabit fiber line. They're using 43 megabits. They hit 6 megabits and then they were done. That was it. And so they're massive packet loss. And so it's so easy to go, oh, the cellular is dropping on me, the connection. But there's also another end to that. There's another piece to that that we also need to pay attention to. And so it's important when you're expressing a problem, stop, slow down, pull yourself away from that and look at the whole connection, not just the one piece that you think is acting up. Because sometimes it's not that piece, it's something else.
Yep.
When you
I see similar things on like the cellular latency. Everything was working great. Now it doesn't work, and you go and look in there, and you'll see cellular latencies of 1,000, 2,000, 3,000 milliseconds, right? And that's your sign that the cellular network is congested usually. And it might have worked a couple hours ago, but that doesn't mean there's not congestion now. And that's your warning sign. It's not a problem on the SpeedFusion necessarily, but
exactly. And so when you run your speed test, you're going to get these nice results. It's going to tell you the retransmits, your throughput, and then kind of give you the 4 threads, and then your total. It's a great way to see packet loss, latency, retransmits, total throughput, and you can see them all. And I'm going to show you a little trick to that as well. Actually, I'm going to do that right now. So let's go into my 5G router, this one right here. So if I go to status, I go to SpeedFusion, and I want to test these 4 cellular and see how they're working, mostly to see if they're being throttled or underperforming. I can click the little caret, and see this right here says remote connections, show remote connections. This then shows me what it's the WANs that it's connecting to on the remote side. If I had a dual Ethernet router, this would say WAN 1 and WAN 2. So I create a long test. So I can say, give me 100 seconds of download. And then I can click start. And then what I start doing is I look at this. I go, okay, 2.3, okay, 44, 9, 4, 7. Okay, let's just pretend this one's like 600 kilobits. Oh, there you go, 300 kilobits. I go, that's weird. And so then I can turn off this WAN and see if the other ones improve. So I'll pick the slowest connections and see if it improves the capacity. Look at that. I turned off Verizon and then my connection. So I had TCP ramp up, which was enabling WAN smoothing for the first 10 seconds. That high throughput was because I was using WAN smoothing. Verizon is only getting 300 kilobits. Now look at my connection when I turned off Verizon. It's awesome. But Verizon was at 300 kilobits. So my Verizon, obviously I've used up all my data and I'm being throttled. I didn't mean for that to happen in this demo, but that was a really cool scenario. WAN smoothing, because it sends parity bits, that just ignored the 2 Verizons that were running slow because the other 2 connections were running fast. And now I'm getting 105 megabits of throughput. And so and if I don't know, I'll just randomly click one. I'll just start playing with them and I'll turn them on and off. That's why I said 100 seconds. Sometimes I use my intuition, like, oh, that one looks like it's slower, or that one went slower first. But I'll turn them on and off, and then you can see now I'm running at 125 megabits per second once I turned off Verizon. Obviously, my Verizon cards are being throttled, probably because I ran too much data through it. But it's a really, really powerful way to see what's going on and to troubleshoot SpeedFusion performance. Other factors are high latency and high packet loss. So I was able to fix this with just throughput, but you also want to pay attention to the latency and the packet loss. If you have high packet loss where the router can't overcome that packet loss with the multiple internet connections or FEC or WAN smoothing, turn the high packet loss ones off and see if that boosts your performance. And so it's an amazing tool that allows you to, and you can see here 1 meg, 2 megs, 1 meg, 2 megs, 1 megs, 2 megs, 11, 17, 100, 100, 100, 170, 80. I mean, way better. And so I was able to solve that by getting rid of that horribly throttled connection. The other thing I can show you, another way to detect that same scenario would be with a WAN analyzer. So if I go to my system and I go to WAN analysis, I can say as a client, and then I need a router that I can pull up that is on it as a public IP on the internet. So I've got my little SpeedFusion overview router here. It's a little Balance 380. So I'm going to pull that up, go to Site B, and I can go to Settings, Device Tools, select it, and go to WAN Performance Server, and turn it on. You can see here that my control port's 6000. If you need to change that for whatever reason, you can change that there. And then there's my public IP. So I copy the public IP, go back over to my client, and go to Cellular 1, Cellular 2, Cellular 3, Cellular 4. And I would expect to see between the four of them around 100 megabits of throughput, because that's what we were getting bonded, 120, so maybe 150 megs. So we'll do download. And I can do TCP or UDP. Tunneling does use UDP, so TCP will be a little bit different. So I could actually set UDP and say, use 30 megs each, but I'll just do a TCP test and hit start. And what I'd like to see is cellular, the blue and the green carrying the most load, and you can see that right there. You see the red and the orange they're getting a little bit of throughput, but the blue and the green are really carrying the load there, and you can see that. The red is almost non-existent, and the throughput there. And so you can see that, like, WAN analysis right there shows me that red and orange are just, red is non-existent. I could probably have turned off the red one and left the orange one and have a little bit of bandwidth there. But when I was doing my testing, that's just what I had done. This lets me see that for real. I can see that Google Fi is carrying a really decent amount of load. AT&T or T-Mobile is killing it down there in the T-Mobile 5G. My red is non-existent, and then I've got that other Verizon SIM that is carrying some load, but I had to shut that off. So this lets me see that in real time. Does that make sense? Oh, you guys can't answer me, so I'm going to pretend you said yes. So great tool, though, is my point. I mean, it's a great tool for troubleshooting your circuits.
Yeah, I like the way you position that. I mean, it's a kind of a beginning step, right? You see what the raw throughput is on all of those links, and then you can use that to kind of predict what you might expect or need to do on your SpeedFusion side. And yeah.
Hot failure test is pretty easy. Let's see if they have a slide for it. Yeah, so like we mentioned earlier, so you can actually do the simulation, which will turn it off and turn it back on. So you can have like cellular 1, cellular 2, or your fiber and then failing over to 5G, hit enable, it'll shut that off for 60 seconds and you should have it. If it fails, it'll turn that back on in 60 seconds. So you don't have to worry about messing up. Sometimes, me, I like to be in person. I'm just going to rip the cable and see what happens. But failover testing is a great way to use that under support.cgi. Bandwidth bonding, we just tested there, so that's good. And GPS forwarding, I'm only going to show it to you. I'm not going to demonstrate that. The setup of it is too much for a lab environment. But if you go, a lot of, especially our first responders, they need to have GPS, especially for like their cameras and their vehicles, going to their CAD systems and things like that. We now have GPS forwarding and GPS receiver. So you can go to GPS forwarding and turn it on, and you can add either NMEA or TIAP, and you can add multiple server destinations here. So if someone tells you Peplink can't do multiple server destinations, They're wrong. There it is right there. The other thing that we can do is actually act as a GPS receiver. And so we can receive GPS signals from a device and actually act as a receiver. Now, if you think about this, say I have I've never done this, so I'm actually talking to this in real time with Mr. Peplink over here. But my understanding is what I can actually have like an HD1 dome transmit to an SDX, and now the SDX is receiving a GPS signal and has an active GPS. Would that be accurate?
Yeah, I mean, sometimes it's very important. Well, not sometimes, it's very important, especially in public safety, to know who's on first, whose location, what is where is this thing, right? And especially when you get multiple devices in a vehicle, you start getting slight differences of like, okay, I've got two GPS antennas and this one said I was here and this one said I was here. But, when you're going to put it all together, you want it all to be on the same data, the same timestamp, the same location. And so this is how you can help do that, whether that's with two Peplink products or other third-party products.
Yep. Yeah. So what's really neat is we now have the ability to actually act as a GPS receiver. Now this is not troubleshooting. This is just a really cool feature, but it's cool in 8.4. So I'm hovering over this. You can see the link right there. There's a software that's linked right there on this. Hopefully you can see. I don't know if you can see it in the video, but we'll try to put a link in the description. But basically, you can download this NEMA settings and you can run this on a PC. Then you can actually act as your own and actually see the GPS settings right there. It's a really cool tool. It's free. You can download it. And it basically is a NEMA router. And it lets you just receive GPS streams from your devices to make sure that they're working properly.
Yeah, and from a troubleshooting standpoint, I think the scenario is, why isn't my Peplink able to talk to this software, or something along those lines? And yeah, seeing that stream is often the answer to why it's not working. It's just formatted slightly different than you were expecting it to, or something like that. But
exactly. Diagnostic reports, as much as you're going to ask questions about this or complain about it, we are not allowed to read them. That is for engineering only. And so there's two ways to, if you're creating a ticket, engineering asks for a diagnostic report, there's two ways to get a diagnostic report. One is from In Control. You can click next to your device name, hit show all, and you can actually download a diagnostic report right there. And the other is from the UI. You can go to status and download a diagnostic report right here. And while I'm here, if Peplink asks you to turn on remote assistance, right there, you can turn on remote assistance. So you have your diagnostic report and you have remote assistance right there on the status device page of your UI. On In Control, you would you can do diagnostic report right there, or you go to settings, device tools, and turn on remote assistance right there and inside In Control. So if Peplink tech support asks you to send a diagnostic report and turn on remote assistance, you do that right from In Control, download that and transmit it. Or if you don't have access to In Control because it's not online, then you can do that from the UI as well. So those things. The other thing that I would like to show you for this, and since we're here, is if you click show all, you also get configuration backups. Every time someone hits apply changes, you're going to get a configuration backup saved. This is incredibly useful because I'll get a call, hey, our network just went offline. What changed last? Nothing. We did nothing. We changed nothing. I pull up and I go to configuration backups. I click download and I go, really? Why do you have 2 changes today? And obviously that's not today, it's on the 5th, but so I can download a copy of those and actually load them up in my lab. Or I can say, you know what? Yesterday you were working. Let me just apply yesterday's configuration file. And I can click apply right here and it actually loads that configuration file to that router. And then we'll activate that configuration. So if they say they made no changes, you can then apply yesterday's config where you knew you had, or the last known good config in a sense. Incredibly powerful troubleshooting, which I'm sure will be in the slides, but since we were right there, I just wanted to show you right there.
Yeah, that's one of those like best hidden features.
Oh my gosh, it's amazing.
Almost anybody can use it, but not many people know it's there.
Yeah, it's really powerful. Geofencing. I use geofencing for my fleet to turn off Wi-Fi when I'm in my property. So anytime we pull up into our building, or our parking lot, I shut off the Wi-Fi on the vehicle. That way we're not accidentally connecting and then wasting data being broadcast. But you can use geofencing to apply tags, to turn on and off Wi-Fi, or to push firmware updates, which we've talked about.
Yeah, I like
So here you go.
for firmware too. Like, you know, if
Yeah.
I've got a fleet of public safety vehicles, what's a good time of day to update a squad car? Well, I don't know.
While it's on call.
Whatever time it's not
Yeah,
out in the streets, right? If it's back at the depot, that's
exactly.
probably a good time, right? So I can trigger firmware updates to only happen when they're parked in the parking ramp and not out doing important things. So
Yeah,
small
it's
feature, big deal.
under settings, geofence. You can create a geofence that's your depot and then say allow firmware updates. Then under firmware management, you have scheduled, immediate, schedule, and then geofence. So if you create a geofence called depot, you can then say apply the 8.4 firmware when they enter the depot. They drive up to the depot, boom, the firmware downloads and loads up, and the router will then reboot. Really cool. Network optimization has changed and is incredibly complicated when you're talking about different mediums. So when bonding similar technologies, you're going to have the most calculatable performance. If I have two 1 gig fiber lines that are 1 gig by 1 gig from two different ISPs, Cox and Unity or whatever, and I'm bonding those together, I'm going to get 1.82 megabits per second, gigabits of throughput. I mean, it's going to be right at the calculated, the stated throughput minus the speed fusion overhead. It's going to be there because the latency is going to be low. It's an SLA circuit. I'm going to be getting 2 gigs of throughput. It's going to happen. Cable modems, not necessarily. They're best effort services. I mean, sometimes I may get in gig. Sometimes I might get 600 megs. Sometimes I might get 400 megs. Sometimes I might get 800 megs. And so when you're talking about variable performing circuits, you can't run a mathematical calculation to say I should get this much throughput on a variable circuit. And so we try to do handle that with dynamic weighted bonding. But as you just witnessed when I did the demo, Verizon was performing so poorly that the router couldn't compensate for that throughput. And really what we should have is like a minimum throughput checkbox. Hey, if I'm running, more than 2 megabits of data and I have a circuit that's getting less than 500 kilobits or whatever, shut that circuit down. But the idea here is that highly underperforming circuits will affect the performance of your bonding. And it's up to us as network engineers or tech support or whatever it is that your job or role might be to understand that. Well, let's just call that job security, right? As much as these systems are perfect or is great, they're not perfect. No system is. And so when we're looking at this, we need to pay attention to latency, packet loss, and how similar the circuits are. The more different the circuit is, the more we need to pay attention to that performance. So using WANs with similar bandwidth within 50% of each other is going to give you the best bonding capabilities, the best calculatable response. If I have a 500 meg circuit and a gig circuit, that's going to be 1500 megs minus my 18% overhead. It's going to work. If I have a 1 gig circuit and a 100 meg circuit, I'm actually going to get less than a 1 gig because 1.1 gigs minus 18% is actually less than 1 gig. So at that point, I'm looking at the fact that I might be just adding some stability to a circuit for that, maybe using hot failover instead of bonding type scenario. So the purpose of this slide is to say, pay attention to the throughput as we just witnessed doing that accidental demo that I just did, where my Verizons when I ran the test previously, they weren't throttled. So they must have hit their 22 gigabytes or whatever it is and then been throttled. Using sources from different ISPs will maximize your total capacity. So if I have AT&T and Verizon and T-Mobile and US Cellular and Starlink and Cox and Unity, as long as they're all different, I'm going to have the best results because congestion will be spread across all the circuits that are sharing the same network. So if I have 3 Verizons or 2 Verizons and one of them and Verizon is being congested, both Verizons are going to feel that. And so it's the diversity is best, But there are places, and I have it right now where I'll have 4 AT&Ts in a network, because AT&T is the only provider in that area. And what you're doing is you're saying, give me the most pieces of the pie. If I've got 10 people on a tower and it's a 100 meg tower, each person gets 10 megs. If I'm 2 of those pieces, I get 20 megs. So the more pieces of that pie, the better we're going to get, but we're still sharing a common pie. And so diversity is great, but when you don't have it, quantity still will beat other single people. Like, so if I've got 4 SIM cards running AT&T versus 1 person getting AT&T, my 4 is going to perform better because I'm getting more time slices, if that makes sense. Might have been too complicated. I apologize if it was. And we are getting really low.
Job security. You know?
Job security. I'm going to skip calculating overhead and latency because we're almost at the end and I want to get some factors. WAN link testing, we already did that. We talked about latency, WAN quality, signal strength, backhaul availability. We talked about the number of devices, and then the right plan. I never really talked about that, but the right plan matters. If you go out and buy a gray SIM card, which is these people that will sell you like cards that are supposedly unlimited, there's no such thing as unlimited. You can argue with me all day long. There's no such thing. Starlink's not unlimited. 5G is not unlimited. AT&T, Verizon, and T-Mobile, they're not unlimited. So we have to combat that the best we can. And we do have ways of doing that. Multiple SIM cards, diversity, spreading the load, reducing the demand per card. But there's no such thing as unlimited. If anybody tells you that, they're lying to you. I'm going to say that, Professor P, around the internet. And so with the exception of an SLA gigabit fiber line, there's no such thing as unlimited. And so pay attention to what you're at, because if you've hit a threshold, you might get a fair use policy that says, hey, you're unlimited, but you're in the top 1%. We had to lower your priority because you just sucked up 2.5 terabytes of data. So pay attention to that. It's going to be really important.
Yeah, and there's tools there, right? There's the custom SIM pools. There's different ways that you can track that, react to that, automate those things. But to your point, Peter, you have to be aware of those as the expert and the person managing these connections. Those will all influence your outcomes, and you got to be on top of it. And we've got tools to help.
And we have the tools to help, but we can see it, and I just demonstrated it. We can see it. Mm-hmm. Firmware, as we get new firmware, read I'm hoping that most of the people on this are tech. Read the release notes. There are guides in there too. It's like, hey, if you're running 6.3 firmware, don't try to load 8.4. It's going to be an undesirable effect. There are the release notes have like, hey, like this is the last generation for this particular model. If you have firmware 7.1, upgrade to 7.2, then upgrade to 8.13, then 8.4. So they have guides in the firmware notes that tell you what you should be doing. And if you're going from a really old firmware to a really new firmware, check the release notes of the different firmware models. You can get those inside In Control very, very easily. Go to In Control, go to Settings, go to Firmware Management. And let's pretend this is a 6.3.4 router. Look at this. All my routers are right there. So I can go, let me pull 7.1.2, download the release notes and check it out. Then I can go, okay, what's my next firmware here? 8.0, 8.0, 8.1. So just read each major release and make sure there's not a note about your router, because a lot of times people go, oh, I just went from 7.12 to 8.4 and now it's crashing and rebooting and stuck on rebooting. We reboot back to 7.12 and then we safely update it properly and then it goes well. So read the release notes, and you just click on the router or the firmware, then click release notes, and you're going to get the release notes for that firmware. Super easy. And then in the release notes on the very front, right there, devices supported, right there. Then important notes. Look at this. For transits, please use special firmware 8.1 special instead of 8.12 GA. I mean, they're right there telling you what to do. For balance 20 hardware, for the following models, the units must be upgraded to 7.12 before 8.0. If you have a BR1, BR1 Mini, BR1 Pro, BR1 Slim, BR2, Soho, you have to go to 712 before 8.0. So they're telling you how to prevent mistakes in the first 9 seconds of the release note. You don't have to read every single thing they improved, but just read the important notices if you're going from a major, like a really old router to a firmware to a new firmware. Just make sure that your router is not noted here in the important notes. It'll help prevent a bunch of tech support problems. It has been an hour. Like I said, there's a lot here. If you like this, please join us in November at the Tech Summit. I love talking about this. I love it. And we didn't have enough time to cover everything in 1 hour. I do want to give a couple minutes for some for some questions. Is that okay, Travis? Can we go a little bit over? Okay,
Yeah,
so we're gonna do a couple questions. And if we don't get to your question, please, Peter at westnetworks.com, Travis at peplink.com. We will get you in the right person. I mean, we have people from all over the world that email us. We will direct you to a local partner, a local resource. We'll get you in the right person if you have questions that don't get answered. So, we do have a Peplink representative here. Adrian said it'd be helpful to have the error states. It would be. We just throw that out there to Peplink. It would be helpful if error code or error states were better visualized. Like I had an example with like an SFP that was unsupported. The logs showed unsupported SFP, but the router just said no cable detected. It would have been really neat if I plugged an unsupported SFP if it said unsupported SFP. And since Peplink watches this video, I like that feedback.
Yeah, and I think sometimes we've done things like an in control, like if there's like a high temperature, we'll put a warning in the in control GUI, kind of like auto detect that, right? And put some sort of visual warning there, or default password's another example of that. But yeah, there's some dots to connect sometimes there that aren't easy to understand or realize that you need to. And I would agree with that too.
Paul asked a good question about command line. Our CLI is very, very, very basic. Most of our tools are designed to be GUI. And it sort of hits the target market of who we support, but also goes into the whole idea of SD-WAN and what we're doing. So unfortunately, our CLI is very limited to basic status only. So you're going to want to, if we don't have the right report or right tool, please email us. Let us know. We'll get that added as a feature request.
Yeah, and I think often the API is the path that folks that are command line friendly should look at. I mean, I know they're not exactly the same, but oftentimes it's what are you trying to accomplish? And you are able to accomplish those things often with the API in a similar manner, at least. But yeah, if there's something we're missing there, definitely feedback is always welcome too.
Somebody asked a question about some routers going offline every 7 minutes for a few hours. I'd be really interested to see the logs. That's where we need to look at your cellular logs. Is the cellular dropping? Is the router rebooting? Is it a power issue? So that's where looking at your WAN logs and your system logs would allow us to see why they're going offline. Because if it goes offline, there's going to be some log that's going to tell you it's gone offline. So my first thing when I see something like that would be pull up the logs, look at my WAN logs. Or is it saying cellular one disconnected? Is it cellular saying WAN failed ping test? What is that and why? Or is it saying the router rebooted and 7 minutes is about the time for a reboot, which means that if it's a fleet, maybe there's a 12-volt power issue. Maybe someone's turning something on that's drawing too much power and the router's not getting its the proper amperage or voltage of power. So I would start there, but if you do need further help, once again, please feel free to email. There are a lot of questions, so I'm trying to pick some good ones that we can grab here. Somebody asked if your laptop in a vehicle can now receive Google Map turn-by-turn directions. Never tested that, but in theory, if you transmit the GPS to your laptop, as long as your laptop has a receiver for GPS and sees it that way, I mean, it'd be a fun test. But I don't know if Google Maps actually has laptop turn-by-turn capabilities anyways.
I mean, honestly, that's kind of a backwards version of what a lot of the public safety agencies implement the GPS
Yeah,
export for.
yep. But they have special software, right? They have the CAD software and it goes in. But the answer is, I mean, if the software supports it, yes. I
Yeah.
mean, that's the
Yeah.
point of GPS transmit.
Yep. Same concept, but yeah, to your point, does the software support it?
We'll add the NEMA link in the description. So that slide that has the NEMA settings link, we'll add that in the description of the video. There's no proper configuration of SpeedFusion bonding. There's recommendations, but as you see, there's also tuning. So someone asked, do you have a link for proper configuration? The reason why we have so many options and capabilities is based on the number of links. I do have a Starlink video, but I will tell you, I had some Starlink performance issues one time, and I enabled WAN smoothing, and it was spectacular. So if you have two Starlinks, try WAN smoothing and see what it does. It won't, that's not for everybody. That's not a generic blanket statement, but if you're having performance issues, try it and see what happens. For me, it was spectacular in that one scenario.
I think the general rule of thumb with SpeedFusion is configure as little as you need to. Like start simple, start small. Don't set a bunch of parameters and
one change at a time.
Yeah, one change at a time. Don't assume that you need to set this or that. Just start basic and then save apply and change it on both sides. You almost always too. That's another trap I see people fall into is they'll change one setting, and sometimes it does make sense in niche situations to not change it on the other side, but almost always you want parity and you want those settings to match, and keep that in mind as you're troubleshooting performance.
If you don't see 8.4 firmware and you only see 8.3, it's possible that your router doesn't support 8.4. So as I mentioned in the firmware options here, in the release notes, like if I go to 8.4 and I pull up the release notes, it'll show devices supported right here, and then important notices. And see this important notices? Further, major firmware will not be supported. They will receive 8.3. So if your router is one of these routers, you can't get 8.4. You'll only get 8.3 maintenance releases. So it might be that your router it might be time to reach out to your partner or distributor and potentially look at getting modern hardware at that point. That was a good question. I like that.
Yep, there's an end of the train for every hardware platform eventually, and we try to push that out as long as we can. But yeah, there are always models in firmware that don't make that cut.
So question says, why can't you show the status of LAN ports? You can on some hardware. So if I pull up my there we go to status. If you go to status Ethernet ports, if your router has a switch port that has the capabilities, there's your status right there. I can see my PoEs on, and I can see that there's nothing plugged into them. So status Ethernet ports will show you. Not every router supports this. That is a managed switch functionality. But if your router does support it, it is right there.
That support CGI page would be the other place to go look if you don't.
Yeah. And then support.cgi. And then you go LAN WAN Ethernet details, and then you can see your connections and their status.
And sometimes you'll see that, right? There's only one LAN listed, but there's 4 ports or something like that. And so that's oftentimes a shared controller. So you don't see each port individually in some cases. Some hardware you do, some hardware you don't.
Paul asked if it'd be beneficial for a part 2. Join me at the summit. I got there right there. So join me at the summit. Let's get some techie people on this. I got it'd be a lot of fun. And then if you can't make it, let me know. But we're gonna do this every year. We did it last year. We're gonna do it this year. We're gonna do it next year. And we're gonna always go with the latest. So it's 8.3 last year, 8.4 this year. Probably 9.0 next year, or whatever the next major release is. And so the new 8.4. How do I get the new Starlink features? We have the Starlink webinar and the 8.4 webinar, but if you go to advanced, if you go to network, WAN, and then right there you can turn on your Starlink. So you click edit and you can say WAN 1 is a Starlink and WAN 2 is a Starlink, and then that'll turn on the Starlink features for you. I think we're at 110. I'm going to do one more question. There's a really cool question that's kind of troubleshooting, but not. There's a question that says, how can I make the balance beyond the Peplink router follow the GPS, follow the router GPS on the map? There's a really cool feature inside In Control. So if I go into In Control and go to my device, so this device details, show all, edit, and there's an option that says follow another GPS location. If I turn this on, I can select a supporting router that's also in this group, like an HD1 Dome, and this balance router or this AP or this whatever. So if say I have like a ship or that has, you know, maybe 2 HD1 domes, a balanced 580, and like 10 APs, and I want all those to move around together. I can have the HD1 domes, select the HD1 Dome as my follow location for the router and the APs, and then the router and the APs will all follow that HD1 Dome around. We use this all the time. It's a great feature. Yep. And at this point, I'm going to say we're out of time for more questions. I love troubleshooting and support. It's one of my favorite topics. I get a little too crazy about it sometimes in our sessions. I would encourage you to join us at the Peplink Tech Summit. If you can't make it next year, if you still can't make that, reach out, let me know. Well, maybe we can set one up in your area or do something with some local partners in your area to get that set up. And then if you have additional questions, please email us. We'll be happy to get you in contact with the right resource to answer those questions, or you can always just schedule a call with me. If you go to sales@westnetworks.com, ask the team, and they'd be more than happy to set up a call, and we can troubleshoot or work through some situations and get you in contact with a good support partner. So, but thank you so much for the time today. Thank you, Travis, once again for another for hosting and giving your valuable time to allow us to share this information.
Yeah, absolutely, Peter. And I'm just typing some more responses here to others in the chat. It's a great topic, and it's always going to be there, right? And so
yeah,
we can keep doing this one.
And someone did ask if we do a part 2. I'll look at how far we made it and see where we were, and maybe do a part 2, a follow up on this, where we can do troubleshooting part 2. So I will actively talk to Travis about if that's what we want to do. If you'd like to see a part 2, if you'd like to see me continue down this path, send us an email. Let us know that, hey, I'd like to see a part 2, and then give me some case studies, give me some scenarios. What would you like to see? How can I help you better learn how to troubleshoot Peplink networks? And if we get enough responses, we'll definitely make that another video.
All right, folks. Thanks again, as always, Peter.
Thank you.
Take care.
Have a good one, guys. Bye.